Next formula, we're going to look at the perpendicular distance formula. It's an important formula because whenever we say what's the distance from a point to a line, it is assumed we are talking about the shortest distance, because obviously, depending on the direction we go, there's lots of different distances it could be, and the shortest distance is always the perpendicular distance. So there's our random point, x1, y1, and line in general form, and that's important for this formula. It needs to be in general form. Okay. So we want to find that perpendicular distance. Okay. Well, basically, we substitute the point into the equation of the line. And so that's why it's important the line's in general form. So once it's in general form, we substitute in that. Now, we have absolute value because we're talking about a distance. So we don't care whether that's positive or negative. We're just coming up with a number for distance. Bottom of the fraction, we basically have it, I guess you could say Pythagoras' theorem, based on the coefficients of x and y. We don't worry about the absolute value there, of course, because we're talking about the positive square root. So that will always be positive on the bottom. So here's an example which you may or may not realise is a perpendicular distance formula question. We want to find the equation of a circle. We've been given the equation of a tangent to that circle, and we've been told what the centre is. Now you may need to remember some circle geometry theorems to work this one out, because if we want to find the equation of a circle, we need two things. We need the centre, which we've got, but the other thing we need is the radius. So how does that relate to the tangent? So the radius is always perpendicular to the tangent. So the perpendicular distance of the centre to the tangent will always be the radius. Okay, so let's sub it into our formula. So in general form, we have 3x minus 4y minus 12. Sub in the point, 1, 4. So 3 times 1 minus 4 times 4 minus 12. Absolute value, because we don't care whether that's positive or negative. Then on the bottom, square root of those coefficients squared. The coefficients are 3 and negative 4. And 25 on square root of 25, which of course simplifies down to just be 5. So we now have the centre and the radius. We can write the equation of the circle, x minus 1 squared, y minus 4 squared, 25. So let's think a little bit about that absolute value. How can we use this for another type of question? And look, you're going to have points where you substitute into the general form, it'll be positive. And you'll have points where you substitute in, it'll be negative. And there'll be points when you substitute in, it'll be 0. Now what can you tell me about the points that you substitute in and you get the answer 0? Yeah, so they must lie on the line because it satisfies the equation. So then logically, some points will have positive numbers, some points will give you negative numbers. They must be on opposite sides. So it is a way of telling whether points are on the same side of a line or on opposite sides of the line. If you sub them into the general form and they both come up with the same sign, so they're both positive or they're both negative, you know they're on the same side of a line. If you sub them in and you've got different values, one's positive, one's negative, then you know they're on opposite sides of the line. So that's another use, I guess, for general form. Okay, well, it's a very quick one for today.